let's dive right into this explainer and completely drop all our assumptions about physical matter. We're so used to thinking of the universe as a collection of things, planets, stars, dust, atoms. We think of reality as tactile stuff we can touch and measure. But what if that entirely misses the true foundational layer of our existence? What if the physical world is just a secondary byproduct of something much deeper, and honestly much stranger? Today, we're going to explore a brilliantly beautiful concept that bridges hard scientific realism with existential philosophy, looking at the very fabric of reality itself. So, what if reality isn't built on atoms at all, but literally on fundamental bits of data? Just imagine billions of glowing cosmic particles freezing mid-motion, and as we zoom in, those particles reveal themselves not as solid chunks of matter, but as binary code, ones and zeros. And then, those binary states dissolve into glowing quantum probability clouds. This is the scientific sublime. It's the mind-bending idea that the entire cosmos, from the smallest quark to the largest supercluster, might just be pure physical information. Section 1. The fabric of reality at its binary foundation. Let's see how this all builds, starting with Claude Shannon's accidental 1948 discovery of a tool powerful enough to describe reality itself. The absolutely crucial point here is that in this framework, information isn't just an abstract idea or some math equation written in a textbook. It is a physical substance. When we really think about this, we have to realize that glowing quantum probability clouds, massive accretion disks swirling around black holes, and the spiraling structure of biological DNA are all fundamentally interconnected. Think about how the intricate web of internet cables perfectly mirrors the spirals of our own DNA. They're all expressions of the exact same cosmic code. They are networks processing data. Moving into Section 2, the physics of information, specifically looking at thermodynamics at the microscale. Now, to prove this abstract concept is physically real, we just need to look at what happens when things heat up. Landauer's principle, the incredibly elegant equation E equals kT natural log of 2, mathematically proves that erasing data is a physical thermodynamic act. When a single bit of data is erased from a memory cell, heat physically radiates outward. This is computation costing actual energy. It's exactly why your laptop turns into a literal space heater when you have way too many browser tabs open. Just the act of flipping and erasing bits of information generates heat. Memory is fundamentally thermodynamic. And this perfectly illustrates the cycle of Maxwell's demon. Imagine a tiny cosmic entity standing between two chambers, sorting hot particles to one side and cold particles to the other, seemingly reversing entropy in real time. But there's a catch, right? To sort them, the demon has to observe and remember which particle is which. It has to store that data. Step by step, a cosmic entity trying to reduce entropy is inevitably undone because its own memory fills up. To keep going, it has to erase its memory. And as we just learned, erasing memory releases heat, which dumps entropy right back into the system. I absolutely love how this summarizes the microscale. Knowledge itself has thermodynamic consequences. Just let that sink in. The simple act of knowing something, observing something, or forgetting something costs the universe physical energy. Your thoughts, your memories, the data stored in a massive supercomputer, they're all physically anchored to the universe through heat and energy. Information is undeniably physical. Okay, let's dive into Section 3 and the ultimate stress test for this theory, the black hole paradox, testing reality at the macro scale. This is where the universe's physics are stretched to their absolute limits, creating a terrifying cosmic mystery. At the edge of a black hole, our two greatest frameworks of physics completely contradict each other. On one hand, classical gravity tells us that when objects fall past a black hole's event horizon, their structural information is gone forever, just crushed into a singularity. But on the other hand, a core tenet of quantum mechanics dictates that information can never be truly destroyed. Instead, as Stephen Hawking theorized, black holes evaporate over trillions of years into static noise via Hawking radiation. The rules of reality clash right at the event horizon, where structural data might just peel off into glowing quantum code. We really have to ask ourselves this profound question. If that data is truly erased from the universe's hard drive, does physics just break? Because if information can be permanently deleted when a black hole evaporates, Einstein's equations and our entire understanding of reality digitally corrupt and collapse. It's like watching the framework of reality flicker and fail. If information can be wiped out, then the past can't be reconstructed and the future can't be predicted. The fundamental continuity of physics just shatters. Which leads us to Section 4, Spacetime and the Hologram. Let's see how this builds into the ultimate paradigm shift, redefining the very dimensions we exist in. What if our 3D reality is just an incredibly detailed projection? The holographic principle suggests that all the information making up the entire three-dimensional observable universe is perfectly encoded on a distant two-dimensional cosmic boundary. So galaxies, stars, planets, and even you and I might just be encoded light patterns, three-dimensional holographic projections radiating inward from a flat cosmic surface. It is fascinating how neatly these cosmic mysteries map directly onto computer science concepts. Take quantum entanglement, where two particles separated by whole galaxies react instantly. It operates exactly like a space-time entanglement bridge. This is the ER equals EPR theory, suggesting black holes might actually be connected through wormhole-like threads. It shows us that physical distance between objects might not even be a fundamental property of reality. Space and time might literally just be emergent properties, woven together by threads of entangled information.
It's a philosophically staggering thought experiment. Imagine the night sky above you. What if space-time itself emerges from computation? What if the quantum foam, that chaotic foundation of the microscopic world, is just buffering at the Planck scale, kind of like a video game struggling to render pixels? What if the physical constants of nature are just editable parameters? Now, we aren't saying simulation theory is a proven fact, but exploring this scientifically opens up breathtaking and frankly humbling ways to understand our existence.
Okay, let's bring it all together in Section 5, the universe computing itself, connecting this terrifyingly vast concept directly back to you, your biology, and your mind. This informational paradigm shifts our entire understanding of life. Classical biology views DNA as merely a collection of chemicals and cells as squishy biological matter. But informational biology sees DNA for what it functionally is: ancient, highly compressed code. Cells aren't just matter. They are microscopic, highly efficient information processing machines, taking inputs, executing algorithms, and producing outputs. Life is literally matter learning to process information more efficiently over eons. Tracking back through time, we can clearly see the universe's relentless drive to compute. 13.8 billion years ago, the Big Bang initiated this massive cosmic information processing event. Billions of years later, that cooling data formed early biological cells, data machines capable of replication. And leading directly to the present day, biological evolution has acted as a multi-billion-year optimization algorithm. It ultimately resulted in the human brain, which is the most dense, complex information processor we currently know of. So the crucial point here is that your consciousness isn't an accident. Your brain is the universe's ultimate, hyper-efficient information processing engine. Neurons fire with patterns that incredibly mirror the cosmic web of galaxy clusters. Your thoughts are essentially recursive information loops. Every single time you learn something, your memories physically alter the structural geometry of your neural network. Through you, the universe has found a way to internally model, reflect, and finally understand itself. When we take a step back and think about all of this, black holes, binary code, spiraling DNA, the vast cosmic microwave background, we are left with a haunting ultimate question. If the universe is fundamentally just data and information cannot be destroyed, then what exactly are we in the grand architecture of reality? We are not observers of the universe. We are something the universe is computing. We aren't just passive bystanders watching the cosmos unfold from the sidelines. We are active, integral components of the code itself. I really hope this explainer leaves you fundamentally questioning the fabric of your reality and eagerly wanting to decode more of the universe's incredible secrets. Until next time, keep questioning the code.